Sir.
Yes, screen is visible to all. Then I am first of all you just write the areas that will be covered in today's class. Yes.
सर वो बोलना था CA2 में मैंने एग्जाम दिया था और टाइम से पहले टर्न इन भी किया था, फिर भी रिजल्ट वाले PDF में मेरा नाम नहीं था.
Okay, you just mail me today. Okay.
Yes sir, I have mailed you, मतलब
Okay.
परसों ही किया था मैंने.
Okay, just today you just mail me. I shall give response. Okay.
Okay sir, thank you.
Now our today's discussion is comparisons test. First of all, test. In this area, we will discuss the portion. First of all, the definition of comparison test, then one example problem, and in this particular part, we will prove the important P series using comparison test. Using comparison test. This is the first part. Then we will discuss about, all of you just write down it. Then we will discuss about the ratio test. Ratio test. Here in this ratio test, first of all you have to prove the theorem. The proof of it using the concept of comparison test and geometric series, using the concept of comparison test and geometric series. Next part, number 3, we will discuss about when ratio test fails. Ratio test fails, then Rabe's test, then some example problem of it. Then we will discuss about capital sigma un by vn. Suppose it goes to a finite limit L. First of all, if un converges, then vn also converges. Similarly, the vice versa, divergence also. Then we will discuss about number 5, the last part of this class. Here we will discuss about.
Sir.
Yes.
Sir, what is the third point, sir?
Yes. Ratio test when fails. First of all, we prove the ratio test. Then we will discuss when ratio test fails, Rabe's test you have to take. Okay. Then the last part of the class we will discuss about series with negative terms. Here, keep in your mind that series with negative terms, not series of negative terms. Okay, series with negative terms. All of you have written, then I can start. If you write it, then I will start.
Yes, sir.
Okay. First of all, comparison test. Come to the particular point. Comparison. Suppose 0 less than equals to un less than equals to vn. Then obviously, if this condition is given, then obviously u1 less than equals to v1, u2 less than equals to v2. In this way, u3 less than equals to v3. Then we can easily conclude that the summation means u1 plus u2 plus ... which is basically capital sigma of ui when I equals to 1 to suppose infinity. Then if this is ui, and in case of v, here you just see that u1 is smaller or v1 than v1, u2 is smaller than v2. So if u1 plus u2 in this way, then suppose these are the some smaller values are given corresponding to each and every term. v1 is some larger than u1, v2 is larger than u2, v3 is larger than u3, in this way, which is represented as capital sigma I equals to 1 to infinity vi. Then obviously if vi, if this very particular sum converges, then the smaller series also converges, because it converges to this sum is converges to a finite limit L, then obviously the smaller series also converges. This is known to all of you? Yes, then I shall proceed.
Yes, sir.
Okay.
Yes, sir.
Then just consider one example problem belongs to that particular part. Suppose suppose 1 by 3 s equals to 1 by 3.
Please show the previous slide 1 minute.
Hmm.
So which you were writing, the previous slides. So 1 minute, please show. Sir, after this.
Okay. But whether it is deleted? Yes. Okay, which person you need? Tell me just 1 minute.
So you were writing that u1 plus u2 plus u3 equals to
Okay,
sigma
okay.
equals to 1 to infinity.
Okay. Just I am writing it. u1
Magnification.
some smaller value, v1 is larger than that, u2 some smaller value, v2 is larger than that. Then this sum, this larger sum, if it is converges, it will be capital sigma vi when I equals to 1 to infinity. If this larger sum converges to a finite limit L, then obviously the smaller sum also converges. So if this converges, this series is convergent, then obviously capital sigma ui also convergent. That I am telling. Okay. All of you have written it?
Yes, sir, but the third test I have not written, sir. The third test which you said, if ratio test fails, then the last
Okay,
test.
so rabbit
Rabbit
test.
test.
RBE apostrophe S, rabbit test. That I shall discuss elaborately. No problem. Okay. 1 by 3 plus 1 by 6 plus 1 by 11 plus 1 by 20. Suppose this is a series. Now here it can be written as 1 by 2 plus 1 plus 1 by, if you are not muting, then I shall mute all. 1 by 6 will be 4 plus 2 plus 1 by 8 plus 3, 1 by 16 plus 4. It can be written as 1 by 2 to the power 1 plus 1 plus 1 by 2 to the power 2 plus 2, 1 by 2 to the power 3 plus 3 plus 1 by 2 to the power 4 plus 4. So in a general term, it can be written as capital sigma 1 by 2 to the power n plus n plus n. So if it is true, then already in case of P series, you know it that if capital sigma in P series 1 by n to the power p, if p is greater than 1, the series converges. Now, if it is known to all of you, then 1 by 2 to the power n, its characteristics 2 to the power n, where n is positive. This characteristic is known to all of you, that 1 by 2 plus 1 by 2 square from geometric series 1 by 2 cube, 1 by 2 to the power 4. The common ratio R is 1 by 2. So it is convergent series. Not only that, here the denominator, you just look, is larger than this 1 by 2. 1 by 2. It is larger than that. So total value is lesser. Similarly, here 1 by 2 square plus 2. 2 square plus 2 is larger than 2 square. So total value will be lesser.
Yes, sir.
Total value will be lesser. So using the concept of comparison test, you can easily see that from geometric series, you know that as R equals to half, it is convergent. So obviously the lesser series is convergent. Is it clear to all of you?
Yes, sir.
Yes, sir.
If all of you have written, then I shall proceed for the next problem.
How it is convergent once again, sir.
Okay, okay.
Sir,
Here you see 1 by
Yes,
2 to
sir.
the power 1,
One second, sir.
1 by 2 to the power 1 plus 1. Look at the denominator. 2 to the power 1 plus 1 is greater than 2. Is it true or not?
Yes, sir.
Then total value of it, 1 by 2 to the power 1 plus 1, is lesser than 1 by 2.
Yes, sir.
Similarly, 2 to the power 2 plus 2 is larger than 2 to the power 2. So 1 by 2 to the power 2 is greater than 1 by 2 to the power 2 plus 2. Is it correct?
Yes,
So, so you see that this very particular series 1 by 2, 1 by 2 square, 1 by 2 cube up to 1 by 2 to the power 4 is larger than this series. Larger than this series. Not only that, from geometric series, you know that as common ratio is half, this series is convergent. R is less than 1. So it is convergent. So obviously, from the comparison test, you come to the conclusion that this series is also convergent. Is it clear to all of you?
Yes, sir.
Yes,
Yes, sir.
Sir,
Now,
can we find the converging value of the series, the given series, the value at which it is converging? This infinite
no.
sum, can we?
you can find the upper
Basically, you have to find out the nature of the series, not the limiting value that it is it attains. Okay.
Okay.
Only nature is sufficient.
Sir, in exam also, can we directly write as R is less than 1, it is convergent?
No, you have to compare it. Always
Okay.
you have to start from some known series.
Take two series UN and BN. One
Yes.
is greater
You
than
have,
one.
you have to start from a known series. Okay. Now you have to prove the important P series 1 by n to the power, suppose P, or 1 by x to the power P, where x suppose 1 to infinity, where x suppose 1 to infinity, or 1 by n to the power P you may write also. So 1 by 1 to the power P, 1 by 2 to the power P, 1 by 3 to the power P, 1 by 4 to the power P. Suppose in the first case, dot dot dot. Now, if you consider that P greater than 1, first of all, you have to look this. 1 by 1 to the power P, this is 1. No problem, just write. But 1 by 2 to the power P, when P is 1, more than 1, then 2 to the power P is 1, mute your 2 to the power P. 2 to the power P is smaller than 3 to the power P. Is it true or not?
Yes, sir.
2 to the power P
Yes,
is
sir.
smaller than 3 to the power P. Then you can easily write that 1 by 2 to the power P plus 1 by 3 to the power P taken as a whole, this sum is less than 1 by 2 to the power P plus 1 by 2 to the power P, because instead of 3 to the power P, you have used 2 to the power P, so lesser denominator. So this value is larger than this quantity. Can it be written?
Yes, sir.
Yes,
Yes,
sir.
sir.
Similarly, 1 by 4 to the power P, 1 by 5 to the power P plus 1 by 6 to the power P plus 1 by 7 to the power P. This sum as p is greater than 1, 1 by 4 to the power p, this is the least denominator. Okay, so it can be written as that 1 by 4 to the power p
4 by 4 to the
plus
power.
1 by 4 to the power p. Yes. 4 by 4 to the power p. So here you just look at this. 2, 1 plus 2 by 2 to the power p plus 4 by 4 to the power p plus 8 by 8 to the power p. In this way it will go. Can it, is it true or not? So
Yes,
it
sir.
can be
Yes.
written as
Yes, sir.
1 plus 1 by 2 to the power p minus 1 plus 1 by 2 to the power p minus 1 whole square plus 1 by 2 to the power p minus 1 whole cube. In this way it will go on. So the sum will be 1 minus 1 by 2 to the power p minus 1 to the power n by 1 minus 1 by 2 to the power p minus 1. Can it be written? So this will go to show the maximum, it will go to a finite limit. Is it true or not? That is 1 by 1 minus maximum 1 by 1 minus 1 by 2 to the power p minus 1 less than this quantity. So it is a finite value. Is it true or not? So you can conclude that using comparison test, if p greater than 1, this series is convergent. Can it be written?
Dad,
Yes.
sir, why have you written that 1 by 2 to the power p plus 1 by 2 to the power p?
To get into GP series.
Just I have converted into a GP series, nothing else. Yes, correct. I have
Sir,
converted
very
into
So with that,
a GP series. You have to go to some known series, na? You have to go to some known series using comparison, so that it will be easier to all of you. Okay, is it clear to all of you? Then I shall proceed for the next part. P less than equals to 1. Is it clear to all of you?
Sir, will it be mentioned in the question for which range of P do we need to find the convergent or divergent series?
No. For first 1 or 2 terms, you just take the summation. Then you will get the result, na? You can easily show that it will be converged. You have to calculate the summation.
Last line again, sir.
Okay. So
Yes, sir.
here
How
1
index
minus
limit?
r to the power n by 1 minus r. Okay.
Upper one, sir.
Oh, this. So this will give a value which is less than this quantity. This quantity is a finite value. This quantity is a finite value. So it is, the series is convergent. You can write. Okay.
Sir, last second line, sir.
Oh, this.
Yeah, yes, sir. How it is coming, sir?
Okay. Here 2 to the power p minus 1. Okay. Here it will be 2 to the power 2p minus 2. 2 to the power 3p minus 3. Is it clear?
Yes, sir.
Okay.
Sir,
Next.
the range is from 1 to
Sir,
infinity. No, 1 by a minus r, na, sir. 1 by 1 minus 1 by 2 power p minus 1 only. Then
Okay.
y
Yes.
in the last conclusion part, sir. 1 minus 1 by 2 power p minus 1 whole power n y.
Yes. So
We
that
consider 1 to infinity.
it will produce a value that I don't know. It will produce a value. But obviously that value 1 minus some quantity by the denominator less than this. This quantity is a finite value. So you can conclude that it is convergent. Okay.
Yes, sir. Yes, sir.
Okay.
we say that this quantity
Next.
is a finite 1 upon 1 minus 1 by 2 to power p minus 1.
Now the next part is when the value of p is less than equals to 1. Then what will be the situation? Suppose 1 by 1 to the power p plus 1 by 2 to the power p plus 1 by 3 to the power p plus 1 by 4 to the power p. You have to write some terms, otherwise it will not be clear to you. 1 by 5 to the power p plus 1 by 6 to the power p plus 1 by 7 to the power p. Okay. Now, excluding these two terms, you just consider 1 plus 1 by 2 to the power p. Consider these two terms. Here you see, as p is less than 1, then this very particular term is less than 1 by 3 plus 1 by 4. These two terms. Similarly, the next terms will be 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8. This will be the sum 1 by 8. Now here you see that you have to prove the divergence. So you have to show that the smaller series is divergent, then the higher series is also divergent. Is it clear or not? In
Yes.
case of convergence,
It's clear, sir.
so you have to get the help of comparison test, so that you have to consider the smallest value. Here denominator 4 is the smallest. So this very particular sum is greater than 1 by 4 plus 1 by 4. Is it true or not?
Yes.
Similarly, this very particular sum is greater than 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. Can it be written? So here you see that it will be 2 by 4, it will be 4 by 8. So every time 1 plus half plus half plus half plus half in this way. So this very particular smaller series is divergent, so that this series is divergent. Is it clear?
So, sir, for
Yes.
divergent, we have to consider the lower series, and for convergent, we have to consider the
Higher
larger.
series. Higher series.
Yes.
So if lower series, if the smaller series is divergent, higher series is obviously divergent. So that you have considered the highest denominator to consider the smallest element. Here highest denominator 4, here highest denominator 8, next highest denominator 16, highest denominator 32. We have to consider in this way, so that it will be 1 plus half plus half plus half plus half in this way. So it is a divergent series. If the smaller series is divergent, obviously this series will be divergent. Is it clear to all of you?
Sir, have you taken p equals to 1 in sir 1 by 3 plus 1 by 4?
If you take p equals to 1, it will become that particular series. 1 by 1, 1 by 2,
n.
1 by 3, that already we have proved.
Yes, sir, in the starting we proved.
Yes, sir.
In the starting we have proved. That is 1 by n, that is divergent series. Okay?
Yes, sir. Yes, sir.
Okay, next problem. All of you have written, then I shall proceed for the next problem. What is in behind the idea of ratio test? Why this concept of ratio test comes, and why you have to first of all prove the ratio test, then you will solve some problems that belongs to ratio test. First of all, we have to consider that what ratio test says, that u n plus 1 by un, if it is equals to r, and this very particular r, if it is less than 1, means un plus 1 is smaller than un. Is it
Yes,
correct?
sir.
Okay.
It is decreasing.
Okay.
Yes, sir.
Now
Convergence.
suppose, and it is convergent. Okay. But how you can prove from the comparison test and from other concepts, from comparison test, from the concept of geometric series, how you can prove this ratio test holds? That you have to go through some conditions. Suppose in a particular case, un plus 1 by un, suppose it is 1/3, then it is the series is convergent. Now the value of r is 1/3. Now the value of r is 1/3. You just consider that in a particular case, un plus 1 by un is 1/3, and that is the value of r. You just consider a higher value than 1/3. This is half. Then half is greater than 1/3. Now you can easily write that un plus 1 by un, that is less than half. Can it be written? Yes?
Yes,
Okay.
sir.
Yes.
Yes,
Now, applying this concept, you can easily prove the theorem. How? That I shall show you. Suppose un plus 1 by un plus 1 by un, suppose it is equals to L. Now you just consider a particular value which is greater than L, but less than 1. In this case, suppose this 1/2. So suppose this very particular value is small l, which is greater than, or this particular value is r, that is greater than l, less than 1. So you can easily write that un plus 1 by un is less than r. Can it be written? So in generalized form, un plus 2 by un plus 1, that is also less than r from this formula. So here just write one line. You have to transfer all the terms into one representation. Like suppose you have to transfer all the terms in terms of un plus 1. Okay, and apply the concept of geometric series. You have to prove. Your target is to, so you just write one line. You have to transfer all the terms into one format. Apply the concept of comparison test and geometric series. How?
Sir, you have written L greater
Sir,
than R.
L less than R. Sir, L should be less than R.
Sir,
No.
have...
I have told you that here you have taken a particular value. Suppose L should, sorry. Yes. You are correct. L should be less than, yes. Here, this is R. So you can easily write, here you just write one line. You have to transfer all the terms into one representation, apply the concept of comparison test and geometric series. Now here you just write one, you just see one thing. Suppose 10 is less than half into 22. Can it be written? So half of 10 can be written as half into 22. Can it be written? So apply this.
Yes, sir.
You just apply the same concept here. Un plus 2 can be written as less than r into un plus 1. Okay. Similarly, un plus 3 by un plus 2, that is also less than r. So un plus 3, that can be less than r into un plus 2. So un plus 3 may be written as less than r square un plus 1. So if you transfer all the terms in terms of un plus 1, so that it will look like this: un plus 1 plus r into un plus 1 plus r square into un plus 1. So this will create a series which is larger than un plus 1 plus un plus 2 plus un plus 3. In this way, can it be written?
Yes, sir.
Okay.
Is equals to
So
1.
from this, if you take common un plus 1, so it will be r1 plus r square plus r cube. And also from previous assumption, r is taken as a value which is l is less than r less than 1. So r is a value which is less than 1. So this series is convergent because it is multiplied with a convergent geometric series. So this series is convergent. So the ratio test is proved from the concept of comparison test and the geometric series. Is it clear to all of you?
Yes, sir.
Okay. Now just you just consider two example problems that belongs to this particular part.
Let's start. When are un plus 1?
Yes. Any question?
So you should start from UN.
Okay. Yes. I have started from an arbitrary value and I have proved. Okay. Partial sum is convergent. Okay.
So please repeat the last part.
Sir, what if n is a large value?
N tends to infinity. N tends to infinity.
Then it will be convergent.
Yes, r is less than 1. That you have considered. Convergent.
Okay, sir.
Is there any need to repeat it? If you say, then I shall repeat it.
That's the last portion when you wrote the series.
Okay.
Last part.
You are telling that un plus 2 by un plus 1, that is less than r, where r is a value which is less than 1. Okay, which is greater than also l, which is l is un plus 1 by un. Okay, equals to. Now here this r is less than 1. So if you can make a geometric series with r, whose value is less than 1, then it will be convergent series, whatever the coefficient may be. Okay, so you can easily write un plus 2 less than r into un plus 1. Can it be written? Similarly,
Yes.
the next term un plus 3 by un plus 2, that is also less than r. So un plus 3 or un plus 3, that is less than r into un plus 2. So r into un plus 2, un plus 2 is less than this. So r into un plus 2. So it can be written as un plus 3, that is less than r square un plus 1. Okay. So if you consider a series, suppose your terms are in this way, un plus 1 plus un plus 2 plus un plus 3 in this way. Now you have considered another terms like un plus 1 plus r into un plus 1 plus r square into un plus 1 plus rq into un plus 1. Now this very particular series, every term here it is larger than this, larger than this, larger than this. So this larger series, if it is convergent, then this is obviously convergent. Is it true or not?
Yes, sir.
Okay. So from this you just take common un plus 1. So it will be 1 plus r square plus rq in this way. And where the value of r is less than 1, so this series is convergent. Whatever the coefficient may be multiplied, this series is convergent. The higher series is convergent, so the lower series is convergent. So this formula is accepted. Is it clear to all of you?
Sir. Yes, sir.
Okay. Next.
Excuse me, sir. So will the value of r be given in the question, or that we have to find out?
That you have to find out. It is less than 1, so it is the convergent. Now suppose some questions that may belong to this particular part. First of all, you just write the question, then I shall proceed for the next. Suppose just I am writing the question here. N by 3 to the power n. Suppose un is n by 3 to the power n. Then what will be un plus 1? N plus 1 by
3 to the power n plus
1. Okay. So what is the value of limit n tends to infinity un plus 1 by un? That will be n plus 1 by 3 to the power n plus 1 into n 3 to the power n. So limit n tends to 1 by 3. Yes. Result is 1 by 3. So the series is convergent. Now can you calculate another problem? Just write. Suppose 1 plus 1 into 2 by 1 into 3 plus 1 into 2 into 3 by 1 into 3 into 5. Now suppose this is the series S. How can you find out the nature of the series? What is un here? First of all, you just write un is factorial n by 1, 3, 5. Suppose for 3. Yes, 2n minus
1.
2n minus 1. So 2n minus 1 each and every time. So okay. So in what is the value of un plus 1? It contains all the terms of un. What is the extra term? N plus 1 by 2 into n plus 1 minus 1. Is it correct or not? This is the extra term. So 2 into n plus 1. So n plus 1 by 2 into n plus 1, 2n plus 2 minus 1. So
I think it will be 2n plus 1 factorial, sir. Sorry, it's not 2n minus 1 factorial. N factorial by 2n plus 1 factorial.
Okay, but I am telling about the what are the extra term in un plus 1.
Yes, sir. Okay.
This will be. So what will be the value of un by un plus 1? All the terms will be cancelled. Only remaining term is n plus 1 by 2n plus 1. What is the value? 1 by 2. If limit n tends to infinity. If limit n tends to infinity, this will give the value half. So this series is
Convergent.
Okay. Now let us another problem.
There will be 2n minus 1 factorial, I think.
Yes, sir.
Un equals
Sir,
2n.
Yes, it will be
2n
factorial.
minus
That's
1,
what
sir.
I was telling.
Product of 2n
Yes,
minus
sir.
1, sir.
Yes, sir. 2n, actually 2n plus 1, if you see it correct. 2n plus 1 factor.
Sir, n plus 1 will
At
be
the
in denominator.
At the denominator.
Yes, sir.
Denominator, product of the odd numbers.
You just see one thing, that at the denominator 1, 3, 5 all are present in the un. What will be in the next term in the un plus 1? That will be one extra term. That will be 2 into n plus 1 minus 1. 2n plus 2 minus 1. So okay, 2n plus 1. This is the extra term. That only remaining. Okay. That only remaining.
When you take the ratio, you'll get that together.
Okay. Next. Next.
Sir, R is coming 0.
R is coming
0 in this case.
Why? Because
No,
n
sir.
plus 1 factorial, na? So
No,
n
sir.
plus 1 is
Sir, it is coming 1 by 2.
1 by 2. It is coming 1 by 2, which is less than 1. So it is convergent. Now you have to consider about one problem when the ratio test fails. That is Rabe's. In case of when the ratio test fails, you just write the formula, then you will solve one problem belong to this particular one.
While solving the problem, why we are taking limit n tends to infinity?
It's supposed to up to infinity because it is basically the series is the every term of the series is a mapping from the natural number to real number. Every term 1 that is a mapping, 2 that is a mapping, 3 that is a mapping. So basically it's a sequence of terms is a mapping. You are taking the summation. So
Good.
next you just see the problem, that is in case of suppose capital sigma of an, here suppose you have to calculate Rn.
Sir,
When
sir.
the ratio gives not, yes.
Sir, coming 0, sir. Previous question, sir.
Yes, sir. It will come 0 only.
Yes, sir. It will come. वहाँ पे मतलब डिनोमिनेटर में वहाँ पे गलत है सर.
डिनोमिनेटर है सपोज 1 by
2n plus 1 into 2n.
1, 3, 5. Suppose for 3 up to 3. So 1, 3, 5. So 1 is 2 into 1 minus 1. 2 into 2 minus 1, 3. 2 into 3 minus 1, that is 5. So in n plus 1th time, what will be the extra term that is coming? 2 into n plus 1 minus 1.
Sir, it is 2n plus 1 factorial.
Why extra term? Sir, if we simply do it by factorial, sir, the un plus 1 by un will come n plus 1 by 2n plus 1 into 2n. And if we
Yes, sir. Into 2n will be there. You didn't get that because you skipped the 2n minus 1 factor.
Why are you taking extra terms? Like, if we do it, it will come 0.
Okay, you just any problem, you just send it to me through mail. Otherwise, continue. Okay. Limit n tends to infinity.
So one extra 2n will come. Yes, sir.
Yes, sir. That you didn't get because you didn't consider 2n minus 1 factorial. So
that you have to take Rn. Here, limit n tends to infinity n into an or an by an plus 1 minus 1. If this value of Rn is greater than 1, the series is convergent. And if value of Rn is less than 1, the series is divergent. Okay, all of you have written the formula?
Sir,
Yes.
sir, how to know the ratio test has failed, sir?
Yes, that I shall show you some examples. Okay.
So what have you written after n equal to? So what have you written after Rn equal to?
Rn greater than 1, then the series is convergent. If
Oh,
Rn
sir.
less
Sir,
than 1, this. Oh, Rn equals
Yes,
Rn equals to limit n tends to infinity n into, in bracket, an by an plus 1 minus 1. As a whole, you have to calculate the value of Rn. And this value is Rn. If Rn is greater than 1, then it is convergent. If Rn is less than 1, then it is divergent. All of you have written? Then I shall proceed for the next. Have you written it?
Sir, please wait.
Yes, sir.
Okay.
Sir, it is occur only when the ratio test is fail.
Yes. Yes. I shall show you some examples. Okay.
Sir,
R is equal to 1
power
ratio test
n
fails.
or a into n.
It has also a huge proof, but this proof is not included in your syllabus. It has a huge proof also. It can be also proven by using the concept that already you have gone through in your function of several variables.
Sir, n is in multiplication of
Can be
power.
proved also. Okay.
Sir, n is in multiplication or in power? A to
No,
the
multiplication. Multiplication with whole. N is multiplied with n is multiplied with the quantity an by an plus 1 minus 1 as a whole. N is multiplied. Okay. An by an plus 1 minus 1, and this is the value of R. Okay.
So that term is n or n factorial that you have written. Limit n to infinity.
No, this is not a factorial. This is not factorial. I have just simple multiplication. This is basically limit n tends to infinity. 1 minute. N tends to infinity. N into an by a n plus 1 minus 1. This value you have to calculate as Rn. Okay. This very particular value, if it is greater than 1, the series is convergent. If it is less than 1, the series is divergent. Okay, all of you have written?
Sir, what if its value is equal to 1?
Yes, good question. But that is also another part of discussion.
Then this test will fail, sir.
Then this test also fails. There are huge possibilities. Okay, good question. Okay, all of you have written?
Yes, sir.
Now just try one problem when the ratio test fails. Write the problem. Suppose 1 plus is equals to 1 plus half 1 by 2 plus 1 into 3 by 2 into 4 plus 1 into 3 into 5 by 2 into 4 into 6 plus in this way. So you can easily write the value of an is equals to 1 into 3 into 5 up to 2 into n minus 1. 2 into n minus 1. Similarly, at the denominator, you just write 2 into 4 into up to
2n.
2 into n. So what will be the value of an plus 1? All the terms are
2n plus 1 factorial by 2 into n plus
2n plus 2
n minus 1
factor.
So what will be the last term? All the terms are same. What will be the last term? 2 into
2n minus 1 factorial by 2n factorial.
Yes. This will be the
term is an.
Other terms are same. What will be the last term?
A1 is not equal to
2n plus 2n plus 2.
You have written an wrong.
Now, if you take the ratio, what will be the ratio?
Sir, n is ranging from 0 to infinity or 1 to infinity?
Yes.
Sir, n is from 0 to infinity or 1 to infinity?
Good question. Basically, here capital sigma n equals
We'll take
1.
it from half because 1 we cannot take. We can take it from half. Second term onwards, this formula will hold.
The 1 plus this something should have been the an.
But the partial sum will be, you can decide on partial sums, no? Because this cannot be considered. You can decide on partial sums. Okay.
Okay, sir.
Now, if you consider this, then what will be the ratio of an plus 1 by an? Limit n tends to infinity. It basically 1 tends to 1. So ratio test fails. Ratio test fails. Now you just calculate Rn equals to an, sorry, not an, n into an by an plus 1 minus 1. What is the value? This is basically limit n tends to infinity. N into here 2n plus 2 by 2n plus 1 minus 1. You have to calculate the value. 2n plus 1 at the denominator. So 2n plus 2 minus 2n plus 1. So now here you just see it tends to half. That means the series is divergent series. That is R is less than 1. The series is divergent.
It will not to half, it will tend to 0.
Sir, it is 1 only.
Because it is reverse, so it will be divergent.
It
So
is
it will be
divergent.
0. Limit n tends to infinity will be 0.
0, sir.
No.
You have
half.
Yes, 0 na.
Half.
Sir, half will come, sir. Half will.
Half will come. Yes,
Why
half will come.
Sir, half will.
Because
First
outside it
multiply
is
n into the
multiplied by
bracket
n.
and then we had to solve.
Multiplied by
2n
n
minus
also.
1 na? 2n plus 2 minus 2n plus minus 2n minus 1.
Yes, sir.
So it will be 1 by 2n plus 1. So n by 2n plus 1. Limit n tends to infinity.
Yes, sir. Yes,
So it
right,
will
sir.
be tends to half.
Yes,
Half
sir.
is less
Sir,
than 1.
n is not written properly, and that is the.
N into. Now is it clear?
Yes, sir.
Now is it clear? Okay.
Yes, sir. This proof is there, sir, for it.
Next problem. Next is, after this all of you have written, then I shall proceed for the next.
So sir, we will consider this test only to find that the series is convergence or divergent.
There are several methods, but some methods we have to discuss. Okay. Okay. Now can I proceed for the next? Anyone? Just response.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Now suppose a series that is available to you, series with negative terms. I have not told that series of negative terms. No, series with negative terms.
So can you show us previous slide one more time?
Series with negative terms. Negative. You just see one thing. Suppose series is a1 plus a2 A3 in this way.
So your voice is very low.
Okay. A series with negative terms. Suppose you are writing -1 to the power n minus 1 an. What will be the situation? -1 to the power 1 minus 1, 0. So a1 minus a2 plus a3 minus a4 plus a5. In this way it will go. Now you see one thing, that if the terms are gradually reducing, means a2 is less than a1, a3 is less than a2, a4 is less than a3, a5 is less than a4. If this is the situation, then you see one thing, that if you a1 minus, if you take common, a2 minus a3 cannot be written, because minus minus plus. Similarly, minus of a4 minus a5 cannot be written. Anyone?
Yes, sir.
Okay.
Yes, sir.
Now this very particular term as a whole, what you forget about the sign, it is a positive quantity because a2 is larger than a3.
Yes, sir.
Yes.
Yes, sir.
Similarly, this very particular term a4 minus a5, this is also a positive term because a4 is larger than a5. Okay. If this will go on, then
You
you
have
are
assumed greater than an plus 1.
some positive numbers you are subtracting from a1. Is it true or not? Each and every time.
Yes, sir.
Yes. So this series is a convergent series because you are subtracting from, so there is some finite value a1, so you are subtracting some positive quantity from a1. So in case of alternating series, if the terms are gradually reducing, then it is a convergent series. Now convergent series also divided into two types of convergence. Here you have to discuss, that is, one is absolute convergence and conditional convergence. Absolute convergence.
Sir, it can go to minus infinity also now. So why we are concluding that?
Because this is a finite value, na? Oh, what you are telling?
Yes, sir. But negative, sir. But negative term, if we are means adding negative term can lead to minus infinity also.
But here you just remember one thing, that gradually it is reducing, na? It cannot go there. Gradually it is
Sir,
All
8
less than
minus
the preceding
A3,
term.
A4
So
minus
let's
A5,
say
all
it
are
is
less than
again
A1, no?
decreasing as -1, -1 by 2, -1 by 3, -1 by 4. It's gradually decreasing only, but it will tend to minus infinity.
It will tends to just less than A1, sir, or 0, I think.
So, sir, it will come under conditional
Sir, we
convergence.
only
No?
consider the
That is why
positive value
yes.
A1, A2,
Yes.
and A3. So
Conditional
therefore does not.
convergence. Suppose I am
it will
giving
come
one
under conditional.
under conditional convergence. Yes. Suppose there is a situation S is, suppose 1 by 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, in this way. Suppose you take the minus common, so 1 by 2 minus 1 by 3, this is positive quantity. Similarly 1 by 4 minus 1 by 5, in this way. 1 by 4 minus 1 by 5, in this way. And you see, these are the terms that are subtracted from 1. And not only that, if you see, this is a conditional convergence, because 1 by 1 plus 1 by 2 plus 1 by 3, this is not absolute convergence, because this is a divergent series, but this is a conditional convergence of that. Okay. Okay.
We have next class also.
Okay.
So the last one series will either lead to 0 or a slightly greater than 0.
Okay, today up to this. Okay, so although alternating series
Sir,
is not
conditional
elaborated,
convergent, I don't get it.
Thank you, sir.
Because its absolute series is not convergent. It is convergent, It is convergent, but its absolute value is not convergent. Okay, absolute series is not convergent. 1 by n. Capital sigma 1 by n limit 1.
Sir, please send the PDF of the notes.
Okay. I shall send it. I shall send it tomorrow. Okay.
Okay, sir.
Okay. So although series with negative terms I have not elaborately discussed, so probably if this is the last class, then that portion I shall omit. Okay.
Okay.
Series with negative terms, some 1 or 2 short questions may be given. Okay.
Okay.
Sir, it was
Okay.
last.
Thank you, sir.
If department will allow, then I shall take another class also. Otherwise, probably this is last class. So I shall upload. I shall upload the slides also. Okay, slide not PDF version of the note. Okay.
Okay, sir.
I
Okay.
Sir, also
Thank you.
programs.
Thank you. Thank you to all of you.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Attendance, sir, attendance.
Thank you, sir.
Attendance.
Automatic download.
Thank you, sir. Thank you, sir.
Thank you, sir.